Okay, hi everyone. So I think if you've met me before, so my name's Mark Cook. I'm product manager for EDEM, or one of the product managers for EDEM. And to help me with that, I'm also going to have Richard Wood cover a couple of the slides. So Richard is from the R&D team, and he's going to cover some of the new physics that is going into this version of EDEM. Okay, so one of the first things to cover, if I can just move the slides on, got a quick introduction of what we're covering here. But I'm going to jump straight into a partnership that we've been working on with a company called GranuTools, and some of you might be familiar with them. But this has been a good partnership. GranuTools create a series of sort of lab scale equipment that is useful for characterizing materials, whether that's powders or dry materials, basically granular materials, as the name implies. And it's able to give you statistics and ideas of how to characterize those materials. And so what we've actually done is we've teamed up with them to create basically a digital twin of these pieces of equipment so that we can exactly replicate the results in EDEM. So on the left there, you can see the piece of equipment. This one is the Granu Heap tool, and this actually does a static angle of repose. So the material is placed into a tube, and the tube is removed, and the resulting angle gives you some idea of how likely a material is to stack up. And so what we are able to do now with the extension to the calibration kit is repeat the same experiment in EDEM. So using this setup means that you can actually then iterate over your EDEM materials to get a good match to what you're actually seeing from a real world material. And that is all going to ship with EDEM 2025.1. So both the example model and the scripts that you need to interpret the results and present them in the same way that GranuTools present them themselves. So that's the first piece of equipment, the Granu Heap powder tester, and then same idea but for another one. So this is the Granu Drum powder tester. Again, also angle of repose, but this time it's a rotating drum. So it gives you more of an idea of the material under a dynamic situation where it's not being allowed to stand still. But yeah, same idea, as I said, included in the upcoming version. So those are both in there. So what I'm going to do now is, I think the next section is moving over to some of the physics changes. So I'll hand over to Richard here.
Right, okay, so as Mark said, my name's Richard, for those that don't know me. And I'm lead R&D engineer, should I say. And yeah, just going to talk through the next two slides. So first off, we have the collisional energy tracking model. So this effectively replaces some functionality which we kind of already have, or enhances, should I say. It's very similar to, we already have the capability to track collisions in EDEM, which is kind of modeling the energy loss, or energy dissipated during collisions. But currently that's only available on CPU. Is that video playing? Don't think it is. So basically in these types of simulations, this is a model of a sag mill. What customers quite often are interested in is looking at the energy dissipated during these collisions. And as EDEM's getting more powerful and leading to simulations with millions of particles, trying to do these on CPU just isn't feasible. But then quite often customers were having to still do it on CPU because this track collisions capability was only on CPU. So now we have this new model. So this collisional energy tracking model is now a model rather than a tick box that it used to be inside the simulator tab. So once you load the model, it will actually register 3 different custom properties, and these are taking advantage of another capability was added, I want to say 1, maybe 2 releases ago, of the counter custom properties. So these are specifically designed for being able to plot spectral plots. So the image at the bottom there is a plot of frequency against the total energy loss, if I can really get it, for a particular interaction pair of materials. So basically, once you load this model, you get access to the total energy loss in collisions, the normal energy loss in the collisions, and the tangential energy loss in collisions. And there's now, as of 25.0, previous one, there is a new tab in the analyst which allows you to plot this data. So this is a new model, but effectively enhancing the existing capability of tracking collision energy data, and now allowing it to be modeled on GPU. as well. So that's the first. And then this is not a new model, but an update, although it was new last release. So as a quick reminder, the liquid bridge model, it's kind of there to model cohesive forces between two elements, so two particles or particle geometry, when they're wet, but we're specifically looking at or concerned about scenarios where it's partially saturated. So we're not in a fully saturated system where you might look at either DMCFD or lubrication model. This is specifically when there are still liquid bridges that you can actually identify as being separate as opposed to a fully saturated system. And the way that this model was working in the past, due to limitations in the API functionality at the time, we weren't able to fully model the way the liquid mass was what's the word, accumulating on each particle. So we would do the maths was handled correctly, but the actual the way we were handling it internally wasn't ideal. So now using some new functionality, it makes things faster. There's no need for the approach we were using before, and so we're just enhancing the liquid bridge model. Additional to that is using yet some more API functionality. So we added, I think it was 2025.0, we added the preserve contact functionality. So the idea being that up until now, you've always needed contact radii to overlap in order to actually register a contact in EDEM. Well, there's now a way that you can actually flag a contact to exist even when particles are a long way apart, and this really enhances can speed up simulations where you don't need to use the contact radius anymore, and that's the same is now true for liquid bridge. So you can still use the contact radius. There's no need to do so if the particles actually start off contacting. The contact is flagged as staying active until the liquid bridge model now says no, that bridge is ruptured, and then the contact stops existing. Again, this is all just improving not just the workflow, but actually making the model faster. And finally, there's also, this is more kind of almost a housekeeping side of things. We're capable of adding custom warning and error messages, and it's there just to kind of help users understand when certain parts of the model might not have been loaded correctly. So there's now there's a system in place in the API to allow us creating the models to provide useful warning and error messages to hopefully guide users to use the models as they see fit. So that's all I wanted to touch on for these.
Okay, so to touch on this one, we've made some improvements to the way we implement cylindrical periodic boundaries. So the previous implementation couldn't go all the way to 180 degrees, as you see here. So it worked on the basis that you were taking a slice of something like a silo or cylinder, but you could set the angle, but it couldn't go all the way to 180. So we've now removed that restriction, so you can now go all the way to 180, because we had certain pieces of equipment where you needed the 180 symmetry. One of the other things that the restrictions that used to be in place was we had to have a way of preventing particles touching themselves at the center. So if you imagine as the periodic boundaries get really narrow in a slice, as a particle moves towards the center of the simulation, it's going to want to contact with itself. So previously it used to be a restriction that you had to place a piece of geometry in the center there to prevent that happening. But we've actually found a way to not need that anymore. So we can allow particles to self-contact, and that works really well. So you now can have a free-flowing system without an additional piece of geometry in the center, and that's a good upgrade as well. There is a note there just to say that these improvements only apply to the GPU solver, and that's really because we just can't get that to work on the CPU. The architecture is different and it can't be used on the CPU version. But with the performance of the GPU, I think that's where most people are using it anyway, so we're not concerned about that as a restriction. Okay, so that covers that item. Yeah, and then moving back to the theme of APIs, so some of the new improvements that will be going into this version that will then start to see improvements coming in to models in later versions of EDEM. One of the ones that we've been wanting to do for a while is to remove the hard link that we had between the mass and the volume. So previously, if you wanted to change the mass of a particle, it had to get bigger. So the density would always remain fixed. So if you wanted to add a coating or something onto a particle, it had to get bigger at the same time. And that's not always realistic. So sometimes you can have a particle that's quite porous, can be quite low density, and you can either get it wet, or you can put a coating on it, or you can put solvents through it, and it will change the density. So there's a number of applications. So the video that you can see here is a quick demonstration of drying. So there's a simple fan there just to indicate that there is some movement of air. But really what's happening is that the mass of the particles is being altered via this new method. So it's a mass scaling factor. So the mass is being artificially reduced. Well, not artificially, but it's being reduced without changing the size of the particles. So they become lighter, and that means that the airflow is powerful enough to lift them off the mesh that you see there. So that's quite interesting in terms of moisture, drying, these types of applications. So again, you will start to see more models appearing to use that. Moving on, some of the areas of API. So another area is just introducing a material manager to match some of the other managers that we have within the API. It's just a simple way of providing information that might be useful to the API writer. So whether that's, as you see there, material names, material IDs, shear modulus values, density, etc., just makes it much easier to pull up the manager and get the information you need for any material that's currently in the simulation. And then the API itself and how it appears in the GUI has had some updates. So we've created the ability to actually assign a title to an API model. Obviously, the models did previously have names, but it was always hard-coded to the DLL, and there were certain restrictions within EDEM that meant that you couldn't have spaces in the name, you couldn't have numbers, special characters, anything like that. So we wanted to remove that restriction. So now there's you basically supply a string of what you want the model name to be, and that's how EDEM shows it within the GUI. We've also removed the separation between the plugin models and the additional models, because the way we're working now in EDEM is these are one and the same thing. So there's now, you just see the slight change in the GUI. And then for models where you've maybe got multiple components together, so you might have contact model, particle body force, factory, all within the same model. It's more of an internal structure, but the way we had things organized in EDEM meant that they would actually be in separate folders. So it wasn't loading the same DLL. And then if you were doing any kind of memory sharing between them, that wasn't working correctly. So again, more of an internal data structure, but it does mean that these types of models now work as intended. And we can create those kind of models as an API, put them into EDEM, and they will appear correctly in the right sections. There's also, it's not shown there, but we now also do a check to establish what type of models a DLL is. So in the list, you'll no longer see random DLLs or anything that you've created, or you won't see, if you were doing that idea of having a combined contact model, particle body force and factory, it would show up in all of the lists because you had to put it in a common place. Now EDEM is actually smart enough to realize that, okay, this includes the functions needed for a contact model, so I'll display it in the contact model list, etc. So another improvement. And then, as Richard said earlier, you can now create custom error messages. So again, helping API writers to improve their models. So if a user has done something that the API writer can detect as incorrect, so they haven't specified a parameter, or they've given a parameter that is outside of a normal range, they can instruct EDEM to pop up a message to give the user some feedback that this might not be suitable, or they might want to change their value, etc. This kind of feedback. Okay, and then more minor things to API, just that we had some inconsistencies between the GPU version of the solver when handling APIs and EDEM running in general. So this is things like having access to field data, then you get the value, the current time value wasn't available on CUDA in the config for timestep function. So it just makes things a bit more consistent. And then the way we were handling material lists, if you're making a custom GUI in the API, it didn't allow you to specify which groups of materials. So there might be situations where you only want to display equipment materials, or you might want to only give bulk materials, etc. So you can now define which material lists you actually want presented in your dialog as you create it. So obviously the picture there just shows an example showing the 3 different categories all in the same dialog. And I think that's about it for the API changes. So some of the other related updates that I wanted to share. So the EDEM AccuSolve coupling, there's some work being done on the AccuSolve side of the coupling to use coarse graining. So this isn't changing the particles on the EDEM side, but it is representing coarse graining on the AccuSolve side. Likewise, a couple of other improvements for the AccuSolve coupling. They can now have initial time. So this is to help with situations where you might have an EDEM simulation that isn't at time 0. So maybe you've had to allow a bed to settle, or you don't need the flow field initially. So it's think of it like allowing a delay to the coupling to start, but still being able to establish the coupling when needed to. And then also these multiplier functions that are available. These can now be accessed through SimLab. So if these are something that you use regularly within your AccuSolve simulation, you can now continue to set that up through SimLab. And then another AccuSolve update, if you've got something like a mesh or a section of foam or something, previously we were creating a mesh in the AccuSolve simulation to represent that. Obviously in EDEM we need the mesh to actually catch the particles. But this new functionality means it's no longer necessary on the AccuSolve side. They have this new porous medium functionality, so they can just define a region and specify it as porous, and that handles the pressure drop, etc., and everything else that they need to handle on their side. So again, just helping to speed up the total simulation time in these situations where that's useful. So I think that's it for AccuSolve. And then just to cover some of the SimLab updates, obviously I think these will be covered in more detail elsewhere. But these are the things that the EDEM team has been involved in. And this is enabling SimLab to define or prescribe which contact models are being used along with all the parameters. So this is something you couldn't do previously. So being able to pick the individual physics models, specify them, and then because of the way the SimLab GUI is, you get this quite nice table in the middle that allows you to see all the values side by side, and it's quite a handy way to do a sanity check on the values you've applied, because you can see them all lined up next to each other. And then the dialog for setting the time step has changed as well. So I think previously that was one of the first things that was defined. Now it's been updated, so it's a bit more intelligent. It can alter the choice based on the model specified, and you get this sort of dedicated panel now rather than it being included in the first panel. Okay, so that's everything we wanted to cover for 2025.1.